करंट करंट का फॉर्मूला होता है चार्ज ओवर टाइम। ठीक है, तो अगर आपको फॉर्मूला याद है तो इट्स इजी टू रिमेंबर द डेफिनेशन कि करंट इज चार्ज पर यूनिट टाइम। करंट की एसआई यूनिट एम्पेयर, चार्ज का एसआई यूनिट इज कूलम, टाइम का सेकेंड्स। ठीक है, कन्वेंशनल करंट जो होता है इट फ्लोज फ्रॉम पॉजिटिव टू नेगेटिव, इलेक्ट्रॉनिक करंट ट्रेवल्स फ्रॉम नेगेटिव टू पॉजिटिव। ठीक है, इलेक्ट्रॉनिक करंट में electrons which travel from negative terminal towards the positive terminal, and in reality electrons ही होते हैं जो travel करते हैं। ठीक है, but we consider conventional current from positive to negative। ठीक है, current की SI unit is ampere and ampere is defined as coulomb per unit second। So we have a numerical. If 15 millicoulomb of charge flows through a circuit in 2 minutes, we have to calculate the current. So charge is given in millicoulomb. For milli, we multiply it with 10 to the power of -3, substitute the values in the formula, and you can calculate the value of the current. ठीक है? Then we have another question. If 50 microampere flows for 2 hours, we have to convert the time from hours to seconds. Next we have is voltage. Voltage is work done per unit charge. So voltage is work done per unit charge. Again, if you remember the formula, so it's easy to remember the definition. Voltage is defined as energy per unit charge or work done per unit charge. Yeah. Yes. And voltage का SI unit is volt. Energy ka is joule and charge ka is coulomb. So it's joule per unit coulomb. Then we have if 1500 joule of energy is supplied by a battery of 12 volt, calculate the charge supplied by the battery. So we'll use the formula of voltage is equals to work done over charge. We have to find out the value of charge, so make Q as the subject. So Q is work done over volts. ठीक है, so work done की जगह we'll write 1500 or voltage is 12, you divide it, you get the value of the charge. फिर अगले part में current मांग रहे हैं. Once you have the value of charge at time, तो I is equals to Q over T. So ये formula हमारे पास आ गया. Now let's look at the difference between the potential difference and the EMF. So potential difference होता है work done per unit charge across an electrical component, और EMF होता है energy per unit charge across the entire circuit. Next, we have the circuit जिसमें we have a battery, we have a fixed resistor and a filament lamp. ठीक है, so the voltage from the battery is being supplied to the resistor and the filament lamp, और उसमें voltage divide होगा. Next, resistance. What is resistance? It is the hindrance to the flow of electrons. When free electrons travel through a conductor, atoms of conductor will vibrate vigorously and they collide with the electrons, hence stopping the path of electrons. If temperature of wire increases, atoms vibrate more vigorously and their resistance will also increase. The SI unit of resistance is ohm. So the formula of resistance R is equal to V over I. Ohm is defined as volt per unit ampere. So ohm की definition बहुत frequently पूछता है 1 mark की. So it's volt per unit ampere. The resistance depends on which two factors? Length and the cross-sectional area of the wire. ठीक है, लेंथ से क्या रिलेशन होता है रेजिस्टेंस का? So resistance is directly proportional to length and resistance is inversely proportional to the cross-sectional area. So thicker the wire, Smaller the resistance, thinner wire has greater resistance. Shorter wire has less resistance and longer wire has more resistance. We merge these two relations and we come up with a formula R is equal to rho L over A, where rho stands for the resistivity, L is the length, and A is the cross-sectional area of the wire. So resistance is in ohm, length is in meter, cross-sectional area is meter square. If you rearrange the formula and make resistivity as the subject, so the unit of resistivity is ohm meter. Sorry. Sometimes it will be given, sometimes it's not. If two wires are made from the same material, so their resistivity is going to be the same. So we have a wire of length 200 centimeter and a radius of 5 centimeter and 20 ohm resistance. We have to calculate the resistivity. So rho is RA over L, resistance is 20, radius is given. So we have to find out the cross-sectional area of the wire using the formula area is equal to pi r squared. So we use the formula area is equal to pi r squared. Convert the resistance from centimeter to meter. So we get this value of area, convert the length from centimeter to meter divided by 100. So once you have length in meters, which is 2 meter, area is this, and resistance is this, put the values in the formula and you'll get the value of the resistivity. So ये 2 mark का वो आपसे 2 या 3 mark का भी पूछ सकते हैं. 1 mark if you write down the correct formula of resistivity. 1 mark is absolute for the answer. And 1 mark if you substitute the values correctly into the formula. Okay? With the correct conversions. So next we have another question. Question read karo.
Wire of length L and cross-sectional area A has resistance R. Another wire is made of same material with double length and 1/3 cross-sectional area. Calculate its resistance in terms of R.
Okay. So when we use the word kg, another wire is made of same material, it means that their resistivity is same. Okay? पहले वाले की length है, area A, resistance R, resistivity we don't know. दूसरे वाले की double length मतलब 2L, cross sectional area is 1/3 मतलब A by 3. We don't know the resistance, but we do know that its resistivity is same as the previous one. तो पिछले वाले की मैंने resistivity अगर calculate कर लेता हूँ, ठीक है? So that can be RA over L. उसकी resistivity put की length is 2L and the cross sectional area is A by 3. ठीक है? Okay, let's just do another question. So we can have a better understanding. And इसको please just solve करो. Okay? Let's just. Question is a wire of length 50 centimeter and diameter D. Another wire of same but length and double diameter length 50 and diameter D and resistance R. Another wire which is made of same material, half length and double diameter. Find its resistance. ये MCQs में भी आ जाता है और ये नॉर्मल क्वेश्चंस में भी आ जाता है इन टर्म्स ऑफ आर. अच्छा, मैं आप लोगों को ना सबसे एक इजी वे ये होता है कि आप वायर 1 और वायर 2 के बारे में इंफॉर्मेशन को सेपरेटली लिख लो. फर्स्ट वाले की लेंथ है 50 सेंटीमीटर. इसका डायमीटर गिवन है. डायमीटर इसका डी है. क्रॉस सेक्शनल एरिया कितना होगा? पाई आर स्क्वायर होता है. रेडियस होता है डायमीटर का हाफ. तो दैट वुड बी पाई डी ओवर 2 का स्क्वायर पाई डी स्क्वायर ओवर 4. So first wire की we know the length, we knew the diameter. Through that we calculated its area. Okay. What is the resistance of this wire? That is R. मैंने ये लिख लिया. जो second wire है, it has half length, which means 50 का half हो जाएगा 25 centimeter. And it has double diameter 2D. So its radius is going to be 2D over 2. That is D. Area का formula pi r square, it's going to be pi d square. We don't know the resistance of the second wire. But we do know one thing, both the wires have the same resistivity rho. Resistivity का formula हमें याद होना चाहिए R A over L. Up based on this, we can use R1 A1 over L1 is equal to R2 A2 over L2. Okay, because their resistivities are equal. So based on that, R1 A1 over L1 will be equal to R2 A2 over L2. Now R1 is R, A is pi d square over 4 whole divided by L1 is 50. R2 is to be found. A2 is pi d square whole divided by the length is 25. Now ये जो अगर फ्रैक्शन में ऊपर फ्रैक्शन आ जाता है तो इसका डिनोमिनेटर नीचे आके मल्टीप्लाई हो जाता है. So it's going to be R pi d square and 4 नीचे 50 से आके मल्टीप्लाई हो गया. R2 pi d square over 25. Now since we have to find out the value of R2, so ये 25 उधर ले जाके मल्टीप्लाई और pi d square इधर लाके डिवाइड करूंगा मैं. मैं बता देता हूँ. सो देखो रेजिस्टिविटी दोनों की इक्वल है. रेजिस्टिविटी का फॉर्मूला होता है आर ए ओवर एल. सो अगर मुझे इसकी रेजिस्टिविटी कैलकुलेट करनी है, सो वी विल यूज द वैल्यू ऑफ R1 A1 and L1. So I can write this as this is A1, this is L1, and this is R1 basically, which is R. So इसकी resistivity और second wire की resistivity equal है. So इसको मैं लिख सकता हूँ L2, A2 and R2. So R2, A2, R2 into A2 over L2 is equal to R1, A1 over L1. ठीक है. क्या चीज? एरिया. क्योंकि इसका जो डायमीटर है वो डी है, इसका रेडियस होगा डी ओवर 2. R2 का डायमीटर डी है. इसका रेडियस d है, डायमीटर इसका 2d है,
इसका 2 का
and double diameter. Okay. So this is how we can calculate the value of R. So 25, 8 times. R over 8. So this is how we calculate the value of R2. Sure. ठीक है, जब भी आपको एग्जाम में इस स्टाइल का क्वेश्चन आएगा तो आपने y1 और y2 को सेपरेटली उसकी इंफॉर्मेशन एक्सट्रैक्ट करके then you can simply equate R1 A1 over L1 is equal to R2 A2 over L2. Okay? Is it clear? If you're done, so we can move to the next question. Sorry, this one. This might come in an MCQ as well for 1 mark. और अगर P2 में आता है तो it can be for 2 to 3 mark. Okay? Done? Sorry? He might ask you in MCQ as well. मतलब definitely you'll have to practice ना, तो once you practice ना तो फिर हो जाएगा इंशाल्लाह. ठीक है? ओके, ठीक है, लिख ली कि लिख रहे हो? इट्स ओके, लिख लो फिर. भी कर पाता हूँ. जैन आपको क्लियर है बेटा?
Yes, sir.
ओके. Okay, let's carry on. अब so we can have मतलब अभी multiple आगे questions है. Okay, next question is drift speed के ऊपर. So we need to remember the formula for the drift speed. I is equal to ANBQ. I stands for current. A is the cross-sectional area of the wire, and small n is the number density, which is calculated using this formula, number of electrons or the positive charges divided by the volume. Small v is the drift speed of the electrons or the charges that flow into the wire, and q, small q is the charge of an electron, which is 1.6 into 10 to the power of minus 19 coulomb. And the volume of a wire can be calculated as cross-sectional area times the length of the wire. Now we have a question. If 20 milliampere current flows through conductor in 2 minutes and the area of the wire is this, and 5 electrons travel through conductor of length 1.2 meter, so calculate the drift speed of the electrons. Okay? So we know the length, we know the cross-sectional area, so we can find out the volume of the wire. volume का formula area into length. How can we find out the number density? Number of electrons per unit volume. So if they have already mentioned that there are 5 electrons, so you will write it as 5 over divided by the volume. ठीक है, then time should not have been given. Yeah. So then you know the current, you know small n, you know area, ठीक है, और charge जो है आप you can use the value of charge for a single electron, then just simply solve it and you get the answer. Sorry?
1.67 comparison.
ठीक है, I'll write another question on board. ठीक है, okay. So solve करो ये question आप लोग. Okay. So if 5000 microampere flows through a wire of radius 8 centimeter and length 20 centimeter, if okay, please do the calculations.
So 400 को एम्पियर में कन्वर्ट करना है
4000 micro.
4000 को like एम्पियर में
Yes.
For 96 or
And radius is given. So first you have to find out the cross-sectional area.
full area of the surrounding area. Then five forms
Okay, so first the radius is given as 8 centimeter. So you can find out the cross-sectional area of the wire using the formula pi r square. Okay, so what do we get? So we get 0.0201. So 0.0201 meters square. Once you have the cross-sectional area, the length is also given, converted into meters. 0.2 मीटर, वॉल्यूम ऑफ फायर हम निकाल सकते हैं, एरिया टाइम्स लेंथ, लेंथ is 0.2, zero point double zero four zero two meter cube. Now we can find out the number density, number of charges, positive or negative, over the volume. So the number of charges are how many? ठीक है, ज़्यादा मैंने लिख दिए हैं वैसे, speed of light ही लिख छोड़ी है. You can let me change this value to 5. Okay, so it's 3 into 10 raised to power 5 instead of that particular value, divided by the volume 0.00402. So we can just write 3 times 10 to the power of 5 divided by the answer, and you get 7.46. 7.46 times 10 की power 367. ठीक है, और नंबर डेंसिटी का यूनिट होता है per meter cube, because there is no unit for the number of charges and the unit of volume is meter cube, so the SI unit of number density is per meter cube. Small m भी आ गया. Now we know we have to find out drift speed. So current is given as 4000 microamperes. For micro, we multiply it with 10 की power minus 6. So it's going to be 4 times 10 की power 3 amperes. Charge of a positron is equal to 1.6 times 10 की power minus 19 coulomb. Formula is I is equal to A N V Q. Make small v as the subject, I over A N Q. So the current is 4 times 10 की power 3. Cross sectional area is 0.0201. Small n is 7.46 times 10 की power 7. And charge is 1.6 times 10 की power minus 19. Substitute the expression on your calculator and you'll get the answer. So 4 times 10 की power 3 divided by 0.0201 divided by answer divided by 0.6 times 10 की power minus 19. So we get 1.66 times 10 की power 3, 6, 9, 12, 15, 16. 1.7 times 10 की power 16 meter per second. So this is how we calculate the drift speed. So first of all, if there is any length that is in centimeter, convert it into meters. If the radius is given, find out the cross-sectional area of the wire. Use the formula pi r square for that. Then calculate the volume of the wire, multiply cross-sectional area with the length. Then you can find out the number density, which is number of charges per unit volume. So once you have that, make small v as the subject, drift speed as the subject in the expression. V is equal to I over A N Q.
Put 10 to the power minus 3.
-3 आ रहा है. Okay, I'm sorry. So we were supposed to have -3 ahead. Okay. So क्या आती है वैल्यू? 74.6. नहीं, 4.47 आ रहा. Okay. नहीं, उससे नहीं फर्क पड़ता. Divided by 7.46 divided by 7, 19.6. So we get क्या आ रहा? 10 ना, ये बाकी तो सेम है, बस ये चेंज्ड है. 4000 into 10 की पावर -6.
CR.
0.0201. हमें 0.6 लिखा हुआ है इधर. हाँ, तो यही आ रहा है 1.67 into 10 की पावर -10. ठीक है, 10 की पावर +10. हाँ. Okay, so this is how we calculate the drift speed using this formula. Zain, is it clear, beta? Hello? Zain, समझ आ गया?
Yes, sir. Clear. Yes, sir.
Let's move. Okay, perfect. 10 power 10 now. So step by step जब करते हो आप कोई न्यूमेरिकल, तो चांसेस ऑफ एरर रिड्यूस होते हैं. और दूसरा ये है कि when you're rechecking something or reviewing something, so it's easier for you to find out a mistake if you have made any. बस ये थोड़ा स्टेप बाय स्टेप कर लो. Okay, next up we have Ohm's law. Ohm's law tells us that voltage and the current, they both are directly proportional to each other, provided the temperature and resistance is constant. So when two quantities are directly proportional, so their graph is always a straight line passing through the origin. Okay? So we have a straight line graph that passes through the origin. The gradient of a voltage against current gives us the value of resistance, or you can use the formula R is equal to V over I to find out the resistance. Current against the voltage का gradient is equal to the reciprocal of resistance. Then we have, how do we, okay, we just have a मतलब graph है और इस पे values are given to us. So we can directly find out the resistance. V over I करके, voltage is 18, current is 1.5 milliamperes. So you'll have to multiply it with 10 की power -2. Gradient भी ले सकते, but you can also use the formula directly. Formula कहाँ पे directly use हो सकता है? जहाँ पे straight line graph हो and it passes through the origin. Okay? So we have a non-ohmic substance. Let's say filament lamp का graph है ये. ठीक है? So filament lamp की resistance change होती है because the temperature is increasing. So the resistance of the filament lamp is also increasing. For a voltage against current graph, we have an increasing gradient, but for the current against the voltage graph, we have a decreasing gradient. Got it? Okay. I'll write down a question on the board. आप उसकी resistances मुझे calculate करके बताओ कि क्या resistances है. That way ये है कि practice भी हो जाएगी. Exam may you will be given a graph, so you should know how to read the values from the graph. Okay, so you have to calculate resistance. Okay, so please calculate the resistance. So you can use the formula R is equal to V over I. किसी एक point की values use कर सकते हो. So voltage is 240 and the current is 6000 microamperes. So 6000 into 10 to the power of minus 6, 40,000 आ रही है value. Are you sure? Please recheck. हाँ ठीक है. So we have this resistance. आप किसी और पॉइंट की भी वैल्यूज यूज करते तो यू वुड हैव गॉट द सेम आंसर. लेट्स से आपने ये पॉइंट के भी कोऑर्डिनेट्स यूज करने थे तो 60 ओवर calculate the resistance for the next point. Graphs given होते हैं ना.
बहुत कॉम्प्लिकेटेड क्या होता है कुछ ना फ्लैश होता है
वो भी करवा दूंगा इसके बाद. मतलब मैं तो अभी कॉन्सेप्ट रिवाइज कर पा रहा हूँ ना कि फॉर्मूलाज आप लोगों के ग्रुप में आ जाए इंशाल्लाह. So calculate the resistance for the next one. इस point पे voltage 10,000 थी. Current was 400 milliamperes. 1 over क्या डायरेक्टली कर लो ना. मतलब इस पॉइंट पे वोल्टेज है 10 किलो वोल्ट और करंट है 400 मिली एम्पेयर. रेजिस्टेंस का फॉर्मूला है V ओवर I. तो V ओवर I की वैल्यूज पुट कर दो डायरेक्टली.
सर
जी बेटा.
सर अगर यहीं पर ग्रेडियंट निकालेंगे तो फिर हमें रेसिप्रोकल करना पड़ेगा.
यस बेटा. अगर आप ग्रेडियंट लेते हो तो यू हैव टू टेक द रेसिप्रोकल फॉर दैट. ओके.
ओके सर.
मिली 10 raised to power minus 3. Yes. Milli is 10 raised to power minus 3. Nano is 10 raised to power minus 9. Meter तो normal unit है. मिलीमीटर भी अगर हो तो milli means you have to multiply it by 10 की power -3. Okay?
आज से मेरा 25 है 25
So we get 25,000 ohms. So you can check your answer, use any other, or you can also use the gradient formula as well. How to use the gradient formula? We have to write down any 2 points. हाँ, but उसमें gradient निकाल के you'll have to take the reciprocal. Which I can also consider, but this is an easier approach to do it. Substituting the values directly in the formula is much easier. No, no, directली मैंने देखो पे वोल्टेज था 10,000 volts, तो मैंने V over I वोल्टेज और करंट की जगह करंट तक देखा तो मैंने डायरेक्टली फॉर्मूला ही यूज किया टू फाइंड आउट द वैल्यू ऑफ द तब भी किसी इंस्टेंट मांगा होगा तो उस इंस्टेंट पे यू कैन रीड द वैल्यूज ऑफ द वोल्टेजेस एंड द करंट्स सॉरी कर्व ग्राफ पे से you don't need to draw the tangent for that. उस स्पेसिफिक इंस्टेंट पे उसकी वोल्टेज और करंट की वैल्यूज को यूज करो ओवरऑल उसमें सेम नहीं है उस पे हर पॉइंट पे वेरी कर रही है okay. So next we have a series circuit. Series circuit पे जो करंट होता है it stays the same, voltage is divided and resistance is added together. ड्रॉ करने लगा जी बेटा बेटा प्लीज सॉल्व दिस So quickly just solve this question. I have just written it on the board for you. Yusuf, please hurry up. So you guys have 2 minutes to solve the entire question. चलो जल्दी से शाबाश पृथ्वी। So find the value of the total resistance of the circuit. How do we do that? We simply add all the resistances together. So that is going to be 2, 3, 4, 4,700. 4,700 ohms. Then we have to find out the current. V over R, 240 divided by 4,700 will give us 0.0511. 0.0511 ampere. So we have the ammeter reading. Yusuf? In a series circuit, the current stays the same, which means that all three of these resistors get this amount of current. Now, if we want to find out the voltages, V1 is equal to IR1. Current is this, and its resistance is 1500. $76.6. $1,200. 61.3 volts. And last में बाद में देखना, थोड़ी देर तक घंटे तक 0. हाँ अभी थोड़ा सा रखते हैं and we are 2000. So it's 102.1 volts. So this is how we find out the voltages and the current for the series circuit. Okay, I hope it's clear now. Ji, Zen, any problem with that? Any problem?
No, sir.
Okay.
No,
Perfect.
sir.
घंटे तक
अभी यू साइन करवाना है सर शाम से मैं अभी वापस कर
मैंने भी करना है उसको घंटे तक दे दो
काम करते रहे कोई इशू बस साइन करवा के मैं वापस आऊँ
क्योंकि मैं इसको भी
उसके बाद काम वापस
क्लास के बाद मैंने इसको फिल करना है उनको बता देना सॉरी जी बेटा
मैडम डीसी सर्किट कल करवाएंगे फिर
सॉरी बेटा
सर डीसी सर्किट फिर कल करवाएंगे
हाँ डीसी वाला जो पार्ट है विल कंप्लीट दैट टुमारो इंशाल्लाह
ओके सर
कल खत्म हो जाएगा परसों विल डू सम पास पेपर प्रैक्टिस ताकि यू गाइस गेट एन आइडिया कि हाउ वी आर सपोज्ड टू implement this.
voltages created can be big name.
Yes. क्लियर हो गया ठीक है ओके सो will हाँ अच्छा चलो पैरेलल भी डिस्कस कर लेते हैं जल्दी से पैरेलल में voltage stays the same, current is divided, and we calculate the resistance using the formula 1 over RT equals to 1 over R1 plus 1 over R2 plus 1 over R3. Okay? And if you have to find out the combined resistance of two resistors in parallel, you can also use this formula, which is R1 into R2 over R1 plus R2. Okay? So this is how you can solve it completely. Is it clear? Any questions? Should I give one question for the parallel circuit as well? Chalo. So quickly, let's just solve another. One. Two resistors are connected in parallel. This is 24 volts, 100 ohms, 150 ohms. This is I1, and this is I2. Okay? So we have to calculate I1 and I2. I1, I2, and I3. 18 volts. So you have to calculate I1, I2, and I3. Okay, so these are the two questions. Also, for the first question, Peter, we can find out the combined resistance using the formula R1 into R2 over R1 plus R2. This is your R1, this is your R2. 100 times 150 whole divided by 100 plus 150. So you can just put the value in this expression and that gives you the value of resistance. 100 times 150 divided by 250 gives us 60 ohms. So this is the total resistance of the circuit. Now for the total current, we have to use the total voltage over total resistance. Total voltage is 24 divided by 60. So 24 divided by 60 is 0.4 amperes. Now to calculate I1 is going to be V over R1. These two are in parallel. They both get 24 volts. So 24 divided by 60, 24 divided by 100, we get 0.24. और अच्छा अब टोटल करंट है 0.4 एम्पेयर 0.4 में से 0.2 एम्पेयर इसको मिल रहा है तो रिमेनिंग करंट जो है वो I2 को मिलेगा so I2 can be I minus I1 so I is 0.4 minus 0.24 that gives us 0.16 ampere okay but for the second question, we can't use this formula. We'll have to use the other method to calculate the total resistance of the circuit. Do this. 1 over 80 plus 1 over 60 plus 1 over 120. So just put entire expression on calculator. So that gives us 3 by 80. And then we have to take reciprocal. It's going to be 80 over 3. $26.7. Oh, the rest is just the same. Okay, you use the formula I is equals to B over R, 18 divided by 26.7. You'll find out I1, 18 divided by 80, I2 is 18 over 60, I3 is 18 over 20. So this is how we solve a parallel circuit. So please complete this question. And the remaining concept and DC circuits, we'll complete that in the next class, inshallah.